Okay, guys, very quickly, we're going to learn base, right? So we look at bases from the beginning to the end. What should we know? We have looked at everything about acids, right? Let's dwell on base. There are a lot of classes under acids that we looked at from beginning to the end. So under base, what should you know? Very simple. The definition of base. Unlike what you already know, please, I beg you, everything that you have learned before about base, acid, base, and so just keep them one side. Follow me as I show you real teaching under base, because understanding is the major thing. Are you seeing it now? You already know what an acid is. If you close your eye, you can define acid. You know everything from beginning to the end. What is a base? Let's go. First, when they say base, I like you to not forget is that a base is either an oxide of a metal or an hydroxide of a metal. You know, a lot of people, right? They have this orientation that, man, I too good, right? Instead of them to humble themselves and learn, they are not ready to humble themselves. So that pride in them will not allow them to learn. Better sit down now and learn a lot of things, because these things will make you to blast your exams. Let's go. What is a base? A base is either an oxide of a metal or an hydroxide of a what? A metal. So two things there. In other words, for every definition of base, right, there are two things you must know, because if you're looking at the example, you must know these two things. The first is oxides of metals. Which oxides of metals do we call base? Potassium, sodium, calcium, magnesium. You see these four, very important. Potassium oxide. You know, potassium is in group 1. Oxygen is in group 6 of the periodic table. And the oxidation state of oxygen is what? -2, right? So potassium is 1. Oxidation state of potassium is 1. Oxygen is what? 2. If this guy change radicals, what will I have? I'm going to have K2O. So this is the formula for potassium oxide. K2O, potassium oxide. Potassium, sodium. Sodium is also in group 1. So sodium oxide, right? Sodium is in group 1. Oxygen, oxidation state of it is what? 2. So if they still exchange their radicals, what am I going to have? I'm going to have your what? Your Na2O. Potassium, sodium. Now, calcium is in group 2. Calcium, right? Calcium is in group 2 of the periodic table. Because calcium is in group 2, oxygen is also as oxidation state of what? 2, right? Good. So that's going to give you 2. If they exchange their radicals, what do you think will happen here? I'm going to have your Ca2O2. The 2 will cancel 2. What will I have there? CaO. So potassium, sodium. Follow me. Potassium, sodium, calcium. So calcium oxide is your what? Your CaO. Potassium, sodium, calcium, magnesium. Magnesium is in group 2. So magnesium oxide, we also give you what? Your MgO. That's what you're going to have there. Sapita, talk to me. Come on, talk to me. Let's go. Talk to me. So oxides of metals. We said that a base is defined either as an oxide of a metal or an hydroxide of a metal. Oxides of metals will form base. Which of them? Potassium, sodium, calcium, magnesium, majorly. So potassium oxide, know their formula. Sodium oxide, calcium oxide, magnesium oxide. Is it clear? Good. This is the first thing I like you to note. Another thing you must hold tight very fast is this. If you watch, all of them, they are metals, right? Potassium, sodium, calcium, magnesium, they are metals. So oxides of metals are called what? Basic oxides. Write it down in your notes. Oxides of metals are called what? Basic oxides. In other words, what's the definition of a base? A base is defined either as an oxide of a metal. We are dwelling on only oxides of metal there. Potassium, sodium, calcium, magnesium. And then we looked at their formulas. Or the hydroxides of what? Or the hydroxides of what? Metals. Metals only. So, under the hydroxides of metals, what should I know? Still, potassium, sodium, calcium, magnesium. But in this case now, the first there is your potassium what? Hydroxide. Don't forget that potassium has oxidation state of 1. OH is, you know, potassium is plus, right? OH is minus. So OH like this, minus, so it will be 1 there as well, right? So if they exchange their radicals, what do I have there? It's going to give me K1, OH1. That is your KOH. So automatically, this is your what? Your potassium hydroxide. Sodium is also in group 1. So what will sodium give you? Sodium hydroxide, NaOH. Potassium hydroxide, KOH. Potassium, sodium, calcium. So your calcium hydroxide, your calcium, and then your what? Your hydroxide. Don't forget that calcium is in group 2, right? Calcium oxidation state is 2, hydroxide is 1. So if both of them exchange, what do you think will happen? Ca will be 1. That Ca, calcium will carry 1, and then OH will now carry what? 2. This is the formula for your what? Your calcium hydroxide. So calcium hydroxide is CaOH2. Simple. And then potassium, sodium, calcium, magnesium hydroxide, MgOH2. Very simple. Are you seeing it now? If you understand this, that means you are good to go. Yeah, let's fire down. So again, very fast. How do you define your base? You said that base is defined either as an oxide of a metal or an hydroxide of a metal. Under the oxides of metals, I've shown them to you. These 4 things, you must hold them tight. Potassium, sodium, calcium, magnesium, oxide. You should know their formula correctly. Potassium oxide, sodium oxide, calcium oxide, magnesium oxide. And then I said that because all of them are metals, right? Oxides of metals are called your what? Your basic oxides. Oxides of non-metals, we call them acidic oxides. Good. Now, hydroxides of metals, we said that base is either an oxide of a metal or an hydroxide of a metal. Hydroxides of metals, what are they there? Potassium hydroxide, sodium hydroxide, calcium hydroxide, magnesium hydroxide. Very easy. If you get this very fast and you understand it. Sometimes there are some questions that they will bring. It will look in a bit kind of like confusing, but they are very simple. A good example is your CaO, calcium, this guy here, CaO and CaOH2. What are the other names? We call them very simple. Your CaO, see the name is short. That's why it is called quicklime. The name is short, quicklime. So your CaO is what? Quicklime. But your CaOH2, right? The one we call your lime water. It's also called your what? Your slake lime. So this is your slake lime, right? Or your what? Your lime water. Calcium hydroxide, also called your what? Your slake lime. Your CaO is called your what? Your quicklime. As we move, you are going to learn these things more interestingly. Again, for the last one, what is a base? A base is defined either as an oxide of a metal or an hydroxide of a what? Metal. Period. You're out of there. If you understand this very fast. In 2002, question 17, look at the simple question they brought. Which of the following compounds is a base? And then they gave option A, CO2, carbon dioxide. This guy is not even a metal. That's a non-metal. Option B, CaO, an oxide of a metal. Option C, option D. Where is the answer? Option what? B becomes the correct answer. Because we said that base is either an oxide of a metal or an hydroxide, right, of a what? A metal. Very simple, easy, direct. You have gotten it. You're out of there. You get this and you understand it to the core. Now look at this. What are the key characteristics of bases? Very simple. We looked at acids. I told you their characters. Now let's look at base. The characters of base, they include the following. Number 1, most bases exist as solids. Bases, are they solids? Most of them. Some can be liquid, but majority of them are what? Solids. That's the first thing. Number 2, most bases are insoluble in water. Will they dissolve in water or they will not dissolve in water? They will not dissolve in water. Majority of them are insoluble in water, but some are soluble. Those ones that are soluble in water, they are special. So basic oxides, right, that are metallic oxides that are soluble in water, that is base that are soluble in water, they will form corresponding hydroxides. Come, let me explain. They say basic oxides, right? Like a good example, CaO, potassium, sodium, potassium, right? Sodium, right? Calcium, magnesium, all these oxides here, they are basic oxides. We said that basic oxides that are soluble in water, not all are soluble in water, but you see the ones that are soluble in water, they will form corresponding hydroxides. So these guys are oxides of metals, but when they dissolve in water, right, look at it now. Sodium oxide, we said that this guy is solid. The character is that most bases are what? Solids. So sodium oxide is a base that is solid, right? If this guy dissolve in water, Basic oxide, is this guy basic oxide? Yes. Basic oxide that are soluble in water. Not all are soluble in water, because we said that most bases are insoluble in water. But the ones that are soluble in water, they will form corresponding hydroxides. If this guy, sodium oxide, dissolve in water, what will it form? Corresponding hydroxide. So it will go and form sodium hydroxide. Yes, that's how it is. And then you can see that this guy is now what? Aqueous. Does it make sense? Good. If you understand that very fast, please, because this guy is reacting with water, I know, let's say for example, you carry chalk, you dissolve chalk in water. Is it a chemical change or physical change? Physical change. But you see, sodium oxide, if it dissolves in water to go and form sodium hydroxide, this one is purely a chemical change. It's not a physical change. Okay, good. And don't forget that soluble bases are specifically called alkalis. Now come with me. You know, as a lady, let's say for example, you are a young girl growing up. There are some guys that will come and be whispering some things in your ears. Oh, when I saw you yesterday, I could not sleep at night. Then my heart was doing me tingly. And then you now be blushing. Oh, thank you. Stop it. Idiot. In other words, out of all the girls in your class, is telling you that you are special. The same thing, out of all the bases, those ones that dissolve in water, they are special. Because they dissolve in water and they are special, we give them special names. What do we call them? They are called alkalis. So soluble bases are specifically called what? Alkalis. So as I move, when you hear me say alkali, alkali is a name that we give to soluble base because it is special. Are you seeing it now? Good. And because the guy is now trying to he's not trying his best to win your heart over. You now they calling you some fine name. Now say pretty. They play. Oh. Then you now carry a phone in the middle of the night. You now carry your mom's phone, right? And you now text him. Don't text me back. This is my mom's number. I just say I should tell you so that you should have my number. Hey, your daddy should catch you first. He will kick you like ball. Does it make sense? If you understand this, special base that dissolve in water, what do we call them? Alkali. That's all. Now that you get this and you understand it to the core, please, I'd like you to pay attention to this very, very interestingly as I explain this to the core. Let's go. You know, we have different, let's start with your base. They are of two types, right? Either oxides of metals or the hydroxides of metals. Now look at this guy now. Hydroxide. Let me point out something important here for you. Now, all these guys, potassium hydroxide, sodium, calcium, magnesium, are they bases? Yes, all of them, they are bases. We said that bases, your base, they are either oxides of metals or hydroxides of metal. So, yes, base, they are all base. Oxides of metals, all of them like this, are they base? Yes, they are base. Basic oxides, all of them are base. But pay attention. Attention is the reason why people will blast their exams. Come with me. Potassium, sodium, these guys are in group 1. Are they alkalis? Which ones are alkalis? Soluble bases. The ones that we dissolve in water, they are alkali. Yes. So you see, potassium, sodium, they will dissolve in water. They are alkali. You now see calcium, magnesium, potassium hydroxide, sodium hydroxide, calcium hydroxide. It is slightly an alkali. Right? You know, these guys that are alkali, why are they alkali? Because they are soluble in water. They are soluble in water. They are very soluble in water. They will dissolve in water. But calcium hydroxide, it is slightly soluble in water. So slightly soluble. It will dissolve, but slightly soluble. You see magnesium hydroxide. Magnesium hydroxide. Is it a base? Yes. But is it an alkali? It is not an alkali. Why is it not an alkali? Because it is insoluble in water. It will not dissolve in water. The ones that dissolve in water, the ones that we call alkali, magnesium, anything magnesium, they don't dissolve in water. Are you seeing it now? That's one important thing you must know. Now, look at this now. Come to leave hydroxides and come to the oxides now. Your potassium oxide, right? Sodium oxide, potassium, sodium. Anything potassium, sodium, man, they dissolve easily. right? They will form alkali. So they form alkali in water. They form alkali in water. Potassium and sodium, they form alkali in water. And when they form alkali in water, they will go and form their corresponding alkali, right? Yes. So they produce KOH, potassium hydroxide, sodium hydroxide. That's what they will go and form. Now, your calcium, I told you that anything calcium, it is slightly soluble. So they will form slight alkali because they are slightly soluble in water, right? Oh yes, even if they will produce calcium hydroxide, but it is light. But you see anything magnesium, whether in the hydroxide or in the oxide state, anything magnesium, they have weak effect. They have weak effect. They are insoluble because they will not dissolve in water. So they now give you exam question. You fail it under this. I will nod you. Look for you to your house. I will give you nodding. Clock it. Clock it. Let's go. Note this very fast and never forget. Again, I like you to understand this, that a base, for example, now I gave you the definition of base. I said that from the definition of base I gave you originally. What is a base? A base is a substance, right? How do you know your base? Either your oxide of metals or the hydroxides of metals, they are base, right? And we looked at all of them. Another way you know your base is that your acid can react with base to form salt and water. So any substance that neutralizes acid is a base. Whether it is metallic oxide or metallic hydroxide, right? Oxides of metals, hydroxides of metals, they are bases. Carbonates, right, of metals, they are bases. And then ammonia is a base. Write it down in your notes. NH3, ammonia, it is a what? A base. Yes. If you get that very fast with me. Number 2, alkali. How do you know alkali? We said that soluble base, they will form what? Alkali. A soluble base that dissolve in water to produce hydroxide ion, right? What is it called? It's called what? An alkali. Very simple. And then you must know this, that please reason it before you answer. All alkalis, are they base? Yes. Because alkali, they are soluble in water, right? Or they dissolve in water. So all alkalis are bases. Correct. This is true. All bases, are they alkali? False. All alkalis are bases, but not all bases are alkalis. That's what you must know, right? This distinction is very crucial that you hold it tight. And don't forget this, that we said that ammonia is a base, but ammonia can exist in two formats. Hold on. Ammonia, NH3, is it a base? Yes. NH3, is it an alkali? It now depends. Are you talking about ammonia gas or ammonia as aqueous? Ammonia gas is a base. Yes, but not an alkali. Which one is alkali? Aqueous form of ammonia is alkali because the aqueous form has dissolved in water. That's why it is alkali. So ammonia gas is a base, not an alkali. Ammonia, the aqueous form, is an alkali and also a base. If you get this very fast and you understand it, in Jamb 2011 question 20, they specifically brought this question. Which of the following is not an alkali? And they brought ammonia. But they did not tell us whether it's a gas or it's what? Aqueous. I wish they just place NH3 like this and they say gas. It is a base, but not an alkali. But this guy, they just gave us NH3, so we don't know. Let's look at other options. Option B, magnesium hydroxide. Which of the following is not an alkali? Potassium, sodium, they will dissolve in water. They will form alkali. Calcium, it will dissolve slightly. Magnesium, it will never dissolve. So this guy is not an alkali. Option B, this guy, potassium, sodium, calcium, it will dissolve slightly. Option D, sodium, this guy will dissolve. So what is the answer? Option B is the correct answer. You are not thinking it. You know it. It is flowing through your veins. That's what I mean by that. Does it make sense? If you understand this very quickly and you get it. 1978 question 49, they brought this question. 5 elements, R, T, W, X, and Y, form the following compounds. A basic hydride. So R here is forming basic hydride. So anything basic hydride, it is an hydride of a metal. So this guy here, first is a metal. and acidic hydride. Acidic hydride is basic, right? That's oxide, that's hydride of non-metal. That's acidic hydride. Y. So your Y there is what? Non-metal. Non-metal. Simple reasoning. Amphoteric oxides are W and X. Amphoteric, so they will have both acidic and basic property. That's your W and X. W and X. These guys are what? Amphoteric. Ampho. Which of the following is an alkali? What's alkali? First. Only you reason it. Alkali is a base, a soluble base that dissolves in water. It's alkali, right? Yes. For you to be a base, you need to be an oxide or an hydroxide of a metal. So metal must be there. Metal. Option what? And that's R will be the answer there. Which of the following elements is an alkali? And then they gave A, they gave B, they gave C, they gave D. The one that has metal becomes the answer there. So what is it? R. Option what? A. And you're out of there. Very simple. Because why is it metal? Base, they are oxides of metals or hydroxides of metals. And we said that soluble bases are called what? Alkali. Option A become the answer. Very simple logic and reason, and you're out of there. If you understand that very fast. In 2013 question 15, look at what they brought. The question say, which ion is responsible for the characteristic property of a soluble base? Which ion is responsible for that? For base. You know, I will just say acid there, you'll be looking at hydrogen ion. But since it is a base, it will be what? Hydroxide ion. Option A, option B, option C, option D. What is the correct answer there? Of course, option what? B becomes the answer, and you're out of there. Which ion is responsible for the characteristic properties of soluble bases? Hydroxide ion. Option what? B. You're out of there. If you get this very fast with me, that's all. I'll see you in the next class. We're going to be looking at the modern definitions of bases. And that class is very important because I'll give you 3 guys that we need to know. Number 1 person is definition of base according to what? Arrhenius. What did he say base is? After that, we look at your Brunstad-Lowry concept of a base. Then we look at Lewis concept of what? Base. You know why we're looking at acid? We treated all these things, right? Under acid. But now under base, we'll look at them according to base. I'll see you in the next class. For the now, peace out. Bye.